Okay, now we want to introduce the formula for the slope of a tangent line. So in this picture, we have a curve. We can think of it as y equal f of x. And this big black line is the tangent line. We also have pictured here a red line, and that's a secant line. And the tangent line and the secant line are close to one another. They don't quite coincide, but they're very close to one another. And that's because the 2 points on the curve that the secant line goes through are close. Those 2 points are close. The closer they get, the closer the red line will get to the tangent line. If these 2 points on the curve, if we move them closer together, or if we move x closer to c, in other words, this bottom point closer to the top point, then the red line will almost be on top of the tangent line. So we see that the slope of this red line is very close to the slope of the secant line. Sorry, the slope of the red line is the slope of the secant line, and it's very close to the slope of the tangent line. And if we move x closer to c, the slope will be even closer to the slope of the tangent line. Okay, so what we're saying, let's just write down, let's remember what the slope of the secant line is. The slope of the secant line is subtract the y's, f of x minus f of c, and subtract the x's, x minus c. So this is the slope of the red line. Now, if x gets closer to c, the slope of the red line will be closer to the slope of the tangent line. Alright, so that's why the formula for the slope of the tangent line is a limit of slopes of secant lines. So if we just stick a limit in front of here, the limit as x goes to c. That's the formula for the slope of the tangent line. The slope of the tangent line at point c comma f of c. Now we're looking at the picture one more time, the picture of the tangent line and the secant line, but this time we relabeled the x-coordinates. Now the x-coordinates of these 2 points are x and x plus h. So let's label these 2 points. The x-coordinate is x, and here in the y-coordinate here is f of x. And here the x-coordinate is x, and the x-coordinate is x plus h, and the y-coordinate is f of x plus h. So let's rewrite the formula for the slope of the secant line using the points labeled like this. Alright, so that would be what we called our difference quotient, f of x plus h minus f of x over h. Okay, remember when we subtract the x's, x plus h minus x, we're just left with h. And like before, if we move these points closer together, that is, if x plus h moves closer to h, then in effect what's happening is h will be going to 0. So if h goes to 0, or if h gets smaller, then x plus h moves over to x. So here the limit that we put in front for the slope of the tangent line is the limit as h goes to 0, because that would move those 2 points closer. So here's another form of the same formula. This is the slope of the tangent line at x comma f of x. So here we have our two formulas. This is the slope of the tangent line to f of x at point C, f of c. And in this limit formula, we're moving x closer to c. And here we have the slope of the tangent line to f of x at x f of x. And in this formula, we're moving h to 0, and that moves x plus h closer to x. In number 4, we want the slope of the secant line through y equals square root x from x equal 1 to x equal 1.1. So here we have a picture of y equals square root x, and here we have a picture of the secant line with x coordinates from x equal 1 to x equal 1.1, this blue line over here. Now it looks like it has a positive slope, and let's approximate the slope. All right, it looks like the line crosses this grid in between y equals 0 and y equal 1. It looks like it's at the halfway mark. So to get from this point to this point, it looks like we go up a half and right 1. So I would approximate this as, I would say that this approximately has slope 1/2. That's what it appears. That's what it appears to have. And now let's actually calculate the slope. Okay, so we're just going to subtract the y values on top and the x values on bottom. Let's first calculate the y values of the 2 points. All right, so when x equal 1, just substitute into square root of x. The y coordinate is square root 1 or 1. And when x is equal to 1.1, all right, let's calculate the y coordinate, f of 1.1. That would be the square root of 1.1. And we'll do this on the calculator. Square root of 1.1. Okay, so I get approximately 1.049. All right, so the slope, subtract the y's on top, and we get 1.049 minus 1. Subtract these two y's. Now subtract the x's in the denominator. That would be 1.1 minus 1. So in the numerator we have 0.049, and in the denominator we have 1.1. Okay, now let's simplify this. We can multiply numerator and denominator by 10, and we have 0.49. So you see it's close to 1/2. That was our approximation. Close to 1/2 or 0.5. Now this line is close to the tangent line at 1, 1, and we are going to see that the slope of the tangent line is actually equal to 1/2. In number 5, we want to find the slope of the tangent line to y equal x squared at x equal 1. And we're asked to use this form of the slope formula. All right, so let's first calculate f of x plus h. In our case, x is equal to 1, so we're doing f of 1 plus h. So that would be just substitute into x squared, that's 1 plus h squared. We're going to FOIL that out. And that's equal to 1 plus 2h plus h squared. And then here we have f of x, and in our case, again, x is equal to 1. So f of 1, that's 1 squared. That's 1. So we're finding the slope, and I'm just going to substitute in x equal 1, the limit h goes to 0. That would be f of 1 plus h minus f of 1 over h. And substitute in 1 plus h, that's 1 plus 2h plus h squared minus f of 1 is 1 over h. These ones just cancel, 1 minus 1. So, oh sorry, here I have to put in, let me not forget to write limit h goes to 0. Until we actually take the limit, we have to keep on writing limit h goes to 0. Okay, so we have limit h goes to 0. Two h plus h squared over h. And notice that we can reduce this. We can divide h into the numerator because every term has an h in it. So let's do that. Let me also say that at this point we can't take the limit by substituting in h equals 0 because of that h in the denominator. We have a 0 in the denominator. So dividing top and bottom by h will take care of that problem. Alright, so we're doing that now. We're dividing by h, and we have dividing the h into the numerator. We have 2 for the first term plus h for the second term. Now we no longer have h in the denominator. Alright, so we can substitute that 0 in for h. And now we're actually taking the limit, so we're going to drop limit h goes to 0. And we see that we get 2. So the slope of the tangent line to y equal x squared at x equal 1 is 2. Now, let's go back and remember the picture that we had in the previous problem when we found the slope of the secant line that was actually very close to the slope of this tangent line. So here's a picture that we saw before. This blue line is a secant line, and it goes from x equal 1 to x equal 1.1. And in the previous example, we saw that the slope of this secant line was 2.1. So that would be slope of secant. Of this particular secant line was 2.1, which is very close to the slope of the tangent line. That's because this secant line is very close to the tangent line at 1, 1. And that's because these 2 points are so close together. In number 6, we want to find the equation of the tangent line to y equal x squared at x equal 1. So the equation of a line, well, we can use y equal mx plus b. Or we can use y minus y1 is equal to m x minus x1. Either formula. All right. This is the slope-intercept line formula, and this is the slope-point line formula. So in this case, we just need, let's just look at this one first, because we can do this one without any work. We can just fill this in. We need a point on the line, and we need the slope of the line. Well, the point on the line is going to be the point 1, 1. When x equal 1, y is equal to 1 squared, which is 1. So we have the point 1, 1. And the slope we just found in the previous example, the slope of the tangent line is 2. So if we just fill this in, we have y minus 1, that's y minus this coordinate, is equal to the slope of 2 times x minus this coordinate, x minus 1. Alright, so that's the equation of the tangent line. If you prefer this form, y equal mx plus b, alright, let's say we want to use y equal mx plus b. We can do that too. What we do first is fill in the slope of 2. And then to find b, we're going to sub our 0.11. We'll sub 1 for x and 1 for y. So that would be 1 is equal to 2 times 1 plus b. So subtract 2 from both sides and we see b is equal to minus 1. So the equation of our line, just finishing this, all right, let's finish it over here, is y is equal to 2x minus 1. These obviously both have to be the same. We can just do a quick little calculation. Both are acceptable, but let's say we want to show that this form is the same as this form. Just simplify this or solve for y over here, and we get y minus 1 is equal to 2x minus 2. And just add 1 to both sides, and we have y is equal to 2x minus 1. So we see they're both are acceptable, both are the same equation of the tangent line. In number 7, we want to find the slope of the tangent line to y equal 1 over x at x equal 1. So this time, let's use the other form. The limit as x goes to c. Either one is fine, really. All right, so in this case, remember x is equal to 1, and our function f of x is 1 over x. So f of 1, let me continue writing limit. X goes to c, or x goes to 1. F of 1, f of x minus f of c, that would be f of 1, over x minus 1. All right, and now let's substitute in for f of 1. Just substitute 1 into here and we get 1. So that's the limit as x goes to 1. F of x is, well, that's our function. Let's write it in 1 over x minus f of 1, that's 1, over x minus 1. We can't substitute in 1 directly here because 1 minus 1 is 0. The denominator would be 0, so we have to manipulate this a little bit. So we're going to just subtract these fractions in the numerator. All right, so we have 1 over x minus the common denominator is x, so that would be x over x for 1. All right, rewrite that. X in the denominator and 1 minus x in the numerator. So notice we have a 1 minus x here and then x minus 1 here. We can cancel, and since they're in opposite orders, we have to cancel and replace with minus 1. So we have the limit as x goes to 1 of minus 1 over x. All right, now we can take the limit as x goes to 1 by simply substituting in 1 for x, because it would no longer make the denominator 0. We got rid of that x minus 1 from the denominator. It canceled here with the 1 minus x. So now we can just substitute in. Substitute in and we get, and then when you substitute in, you drop this limit notation. Minus 1 over 1, or minus 1. So we see that the slope of the tangent line to y equal 1 over x at x equal 1 is minus 1. And now let's recall a previous example where we found the slope of a tangent line that was of a secant line that was very close to this particular tangent line. So let's look at that picture. Okay, so here's a picture from a previous example where we calculated the slope of this blue tangent line, this blue secant line from x equal 1 to x equal 11 over 10, or 1.1. and we found that the slope was approximately minus 9.09, which is very close to minus 1. All right, so basically we expected the slope of the tangent line to be minus 1 from our previous calculation. And finally, our last example, number 8, we want to find the slope of the tangent line to y equals square root of x at x equal 1. We could use either form for this slope of a tangent line, but I'm going to stick with the one that has c in it. So let's do that. So we have the slope, we're going to use this formula, equal to the limit as x goes to c of f of x minus f of c over x minus c. So in our case, c is equal to 1. So we have the limit as x goes to 1. F of x is square root x. F of c, substitute 1 into square root of x. Square root of 1 is 1. And x minus c would be x minus 1. So we see that we can't take the limit by substituting in 1 because of the x minus 1 in the denominator. So we have to somehow cancel that x minus 1 with an x minus 1 in the numerator. So we're going to do a little manipulation that we saw before. We're going to multiply top and bottom by the conjugate of square root x minus 1, which would be square root x plus 1. And we have to multiply numerator and denominator by square root x plus 1. All right, and we got FOIL the numerator, and we have x, root x times root x, that's x. Since these are conjugates, the middle term cancels. That is, the outer is square root of x, and the inner is minus square root of x, so those cancel. And less times less is minus 1. And then let's multiply the denominators, but let's not FOIL them. Let's just write x minus 1 times square root of x plus 1. Again, I have to squeeze in here limit x goes to 1. We didn't take the limit yet, so we have to keep writing that. All right, now we can cancel. This x minus 1 cancels with an x minus 1 in the numerator, so that's why we did this manipulation. We wanted that to pop out, that x minus 1 in the numerator. Okay, so let's do that. And we're left with limit x goes to 1 over square root x plus 1. All right, so now we can actually substitute in x equal 1 because we'll no longer get 0 in the denominator. So let's do that. So we'll just substitute in, and we get 1 over square root 1 plus 1, that is 1/2. And again, we're going to recall a previous example where we found a slope of a secant line that was very close to the tangent line at x equal 1. So let's take a look at that. Here's a picture from a previous example where we looked at the slope of the secant line through y equals square root of x from x equal 1 to x equal 1.1, and we found the slope of that secant line was 0.49, which is very close to 1/2. All right, which is, so we sort of expected the slope to be equal to 1/2 because of this previous example.